There are multiple parachute manufacturers that make different models of parachutes. Each model of parachute also has a size number associated with it. So for example, a Navigator 280 is about 280 square feet of material as determined by the length times the width of the canopy. You can also have a Navigator 280, a 260, a 240, and so the different models of parachutes can come in different sizes. Wing loading is another concept that you need to start becoming more familiar with. Wing loading is the amount of weight the canopy is carrying compared to the size of the canopy. You can also think about it in terms of how much weight does 1 square foot of the canopy carry. In order to determine the wing loading, you take your exit weight, which is how much you weigh, and you divide that by the square foot of the canopy to give you the wing loading. In the example to the right, we have two parachutes that are the same model and the same size in square foot. Both of them are 150 square feet. The one on the left is carrying 300 pounds. The one on the right is carrying 150 pounds. So we would say that the wing loading on the canopy on the left is 2 or 2 to 1. That basically means that for each 1 square foot of canopy, each square foot is carrying 2 pounds. And the canopy on the right is a 1 to 1 wing loading because 1 square foot of canopy is carrying 1 pound. As part of your A license, you'll need to know how to calculate your wing loading for the different canopies that you will be jumping. Each canopy manufacturer has different recommendations as far as what wing loading someone should jump based on their experience and how much they weigh. Canopies with the same wing loading will also respond differently. In the graphics to the right, both canopies are wing loaded 1 to 1. 1 square foot of canopy is carrying 1 pound of the weight. The parachute on the right is a 100 square foot canopy, about half the size of the 200 square foot canopy. Smaller canopies, even with the same wing loading, are going to be more aggressive than larger canopies. Different models of parachutes can also respond differently at the same wing loading. A Navigator 220 is going to fly very different than, let's say, a Pilot 220. So what do all these wing loadings and sizes have to do with you? Well, the higher the wing loading, so the more weight you have under a canopy, the faster forward speed it's going to have, the faster turns are going to be, the more it's going to dive, the more violent malfunctions can be, and the more skill it takes to flare that canopy. And that makes sense. If you think back to the photo where 300 pounds were suspended under a 150 square foot canopy, you can imagine that the more weight something has underneath of it, the faster things are going to happen. On the other hand, the opposite is true for light wing-loaded canopies or large canopies. With large canopies, there's not as much weight under them, so you're going to have less drive against strong winds. The turns are going to be slower, everything's going to be a little bit more forgiving, and they're going to be a little bit less predictable in turbulence because with a lighter wing loading, the canopies don't get pressurized as much because they're not flying as fast forward. You may notice as you start jumping some of the smaller student gear, the landings end up being a little bit better. This is because the forward speed gives you a little bit more lift when you go to flare the canopy. But this is only true to a certain point. Don't think that if you continue to downsize, you're always going to get more lift. At a certain point, the weight underneath of a smaller canopy becomes harder to control and you end up having to run or slide out a landing. You will learn to control your canopy in several different types of conditions, especially that's true for landing. Just because you can land a smaller canopy safely in ideal conditions doesn't mean the smaller canopy is a good decision overall for any condition that may come up. More highly wing-loaded canopies will also stall at a higher airspeed. This is a great chart that shows the USPA's recommended canopy size based on your exit weight and your total jump numbers, and it's really used more as a guide. So in this example, let's say we weigh about 200 pounds with full equipment, all of our gear on, and we have about 40 jumps. Well, if we follow the two blue lines, we can see that in bold, the recommended canopy size is 230 square feet. The number in bold is the suggested canopy size, and the number in gray below that is the minimum recommended size. In this specific example, a 230 square foot canopy is suggested. Now we're going to break down the flare into a little bit more detail. Remember, a faster forward speed can generate more lift during a flare, only to a certain extent. Once you turn in onto your final approach, you're in full flight. In this configuration, your canopy is angled toward the ground, and we can see the first 3 parachutes in this graphic. You're in full flight, your hands are all the way up, your feet and knees are together. As you begin the flare, your canopy starts to angle up at a higher pitch, and your body swings forward underneath of the canopy. In the full flare position, your canopy is going to pitch up, you're going to swing up, and your goal is to time the flare so that your feet touch down just before you start to swing back underneath of the canopy. As you swing back under the canopy will start to nose forward, entering what's called a dynamic stall. At a higher altitude, if you do a full flare, enter the dynamic stall, and hold the flare, you can enter a full stall. Wind turbulence can also affect the way your canopy flies and flares. You'll find turbulence in different areas over the ground, but most notably behind buildings or other structures that generate turbulence as the wind flows over them. The distance that turbulence may affect a canopy could be 10 to 20 times the height of the obstacle. The likelihood of turbulence and the effects of turbulence will increase with higher wind speed. You can also experience turbulence near runways, alongside roads, or where 2 different colors of terrain meet. You can actually get some turbulence over that difference in terrain. Or if you're flying behind another canopy, you'll feel their turbulence. Or irregular terrain such as wind rolling over hills, valleys, gullies, or ditches can also cause turbulence. Running aircraft also have turbulence that gets pushed behind them from the propeller. When flying in turbulence, you want to use a smooth toggle input and fly as full speed as you can, unless your manual says different. Because of how the turbulence may affect you during the flare, you want to prepare for a PLF. There are a couple other things to remember about your landing pattern. The turn from your base leg to the final leg is the most dangerous portion and the most dangerous turn in your landing pattern. On calm wind days, it can be difficult to determine what landing pattern to do or draw on the board for your jump. Sometimes the wind flag changes direction multiple times because the winds are so light and variable. In this case, it's usually best to follow the landing pattern that you planned on doing on the ground. So if you're under canopy and you see that the windsock or wind flag is kind of changing directions variably in light, calm winds, go with the landing pattern that you originally planned on. Now, if the winds change drastically and you can clearly see that winds have picked up strongly, you can make the decision to change the landing pattern. It does take more skill and situational awareness to change your landing pattern while you're in the air. So be very cautious about doing that if you decide to change your landing pattern. This can also be more dangerous if the other jumpers around you don't know what you're doing. So before you go up, check with the drop zone to see what the procedures are for changing the landing pattern while in the air. And also keep in mind that a downwind landing is better than doing a low turn near. For normal landings, you should only attempt to do a stand-up landing if you're in control and you're confident you'll be able to stand it up. Always be prepared for a PLF, but then if the situation's good, you can stand up the landing.